Hey everyone, it's Ash here and welcome back to my advanced Roblox scripting tutorials. In this series, we're learning how to script in Roblox the more advanced way and hopefully to make you a better Roblox Studio scripter and make some better games. Now, following on from last video, which I will put in the description and it's in the playlist, we're going to make this fully functional data saving player class. It allows you to store data for the player and it allows you to save it to a database and load the player's data. I'll show you what we're going to make today. So the player will be able to join, and if it's a new player, no data will be found. And this is our player class, and the player class stores the age, character, coins. You'll be able to leave the game and it will save your data, and then you'll be able to rejoin the game. And once you rejoin the game, the data was found, a new player joined, data was found, and you'll still have the same player class. And this is the data that was saved into the database, and this works on the server. So we're going to use some concepts from the previous video, so let's get started. So the first thing we're going to do is set out our script, and we're going to use server script service because we want our player data to be saved in the server, not the client. If we save the data into the client, then hackers and exploiters will be able to exploit and change their data using executable scripts. You won't make any money from your game because the hackers will just be changing their coins to infinite, and then what's the point of even having a currency? So we're going to need a server script here. This server script I'm just going to call server for now. In a real life scenario, I'd probably make a server class that holds all the player classes, all of the data. Now in this server class, we want to set up some services, variables. We also want to set up some functions, and we also want to set up some events. Now the services we want to set up are the player service. This service will get the players and everything you can do with the players in the server. We also want the data store service because what we want to be doing is saving our data to a database. Now if you don't know how the data store service works, basically you have this table of data and you save player data and then retrieve it when they next join the game. And it's basically just stored in a giant table where you can access it based on a unique key. And in this case, our unique key is going to be the player ID. You can make it whatever you want as long as the key is unique. We're also going to need the HTTP service. When we save our data, we want to save it in a JSON format. Now JSON is just a way of storing data, so the server has to store all of the player data so that we can save all the data once the server finishes and closes down. So we need a table of player classes, and I'm going to call them player classes because our player class is going to be called player class. This is how it's going to be formatted. It will just be the player ID and then that will just equal the player class. This is just how it's going to be set out in the table, so there'll be multiple of these. It will go down in a list. Every time a player joins, it will be added to this list and it will kind of look like this, and each one will have a unique ID. So I also want to create this new table called on join table, and we're going to leave this blank for now, but what I'm going to be doing is checking to see if the player has already got data stored in the database, and if it does have stuff stored in the database, then we're going to create a function that runs if it's stored, and if it's not stored, which will be this false value, then we're going to run this function instead. And this just makes it so we can determine whether we need to create a new class for the user or we need to update a pre-existing one that's already existing inside the database. We also need to create a variable that stores a player class database name. So if we call it player class DB, and we're going to use the data store service that we defined up here, you can call this whatever you want, but we're going to create a database. I'm going to just call get data store. The get data store method, what this does, in your game you might have three databases. Maybe there's one called players and there's one called leaderboard and there's one called daily wins or whatever. Data store will allow you to get that database. And if that database name doesn't exist, it will just create a new one or a brand new table. So this basically gets the table. I'm going to call the database player class data because that is what we are getting here. We're getting the player class data, and that's what we're saving to the database. So now we've got all our variables set up for what we need to do. We're going to start with events. When do we want to create a player class? Well, we want to create a player class when the player joins the game. So we want to use the player service to check if a player is joining or leaving the game. So we can use the player service.player added method to fire a function when the player is added, and we can create a function up here called function player joined. And instead of putting a function here, we can just put player joined. So now we've connected this event, the player added event, to the player joined function. So when a player connects, we will have the player joined, and we do need to pass in the player that joins here. We also want to do the same for player leave. So if we create a function player leaves, then we need to do ps.player removing player leaves. So now these two events have been set up in the server. So when a player joins, this function will run, and when a player leaves, this function here will run. Now in terms of functions, we're also going to want a save function, and I'll set up the parameters in a bit, but there are some parameters we need to put in. Now, the final event that I want to add, there could be a case where, let's say on the screen here, this is the list of players in the game. Now, what happens if there's one player left and that player leaves? Well, the server's going to shut down. The player removing function is not going to run, so we need to add a final check. So what we can do is use the game bind to close function, and what this will do, it will run when the server shuts down. So when the server's about to shut down, this is the last thing that will run, and what we can do is loop through our player classes, and we can save each player class to our database. This makes sure that if the last player leaves, all their data gets saved, just in case the player data doesn't save before the player leaves and everything shuts down. We're going to call a function like that, and we will put something in here, but first of all, we're going to start off with the player added. So if a player joins, what do we want to do? Well, we want to get their ID, and we want to check if there is data in their database. So how do we get the player ID? Well, we can do player ID. So to get the player ID, we can do the player service, and we can get the user ID from the name of the player, and then we can just pass in the player.name. So this line of code here, the get user ID from name async, will fetch the player's ID based on what their name is, and to get their name, you can just do player.name. Now that we have the player ID, we can now pull the database, find out if it has any data stored relating to that user's ID. So for an example here, let's say you have me and you want to collect the data related to my ID. So my ID here, I'm going to pass in my ID, and it should return anything related to my ID from the table. If it doesn't exist, it's going to return nil. That's the aim of this player join function. And the way we do this is by calling a pcall function or a try exception function. And in this pcall function, we have a success variable and a result that is returned by the pcall. So when we're in the pcall, we have to return something to get the result, and success will be if it worked or not. We want to look inside the player class DB. In this database, we want to get async, and the get async method allows you to pass in a unique identifier or the unique ID, and it will return the data linked to that ID, which is exactly what we wanted. And we're just going to pass in the player ID because we're going to use the player ID to identify each player. We can add a check here to see if it was not a success. Then we want to, let's warn, and we can say data was not loaded. So now that we've either successfully got our data or unsuccessfully got our data, we can now check to see if our data exists, and we can run a function from our onJoin table set of functions depending on what our variable is. So we can call our onJoin table, and in this square brackets, we want to either call a true or false value, and that true or false value is going to be whether result is equal to nil or result is equal to null. So the reason why we use the double equals here is because we're trying to return a true or false statement. It's underlined in red right now because we're trying to call a function with this. It's not liking it, so we need to put brackets here. We're calling a function, and any function that you call, you need to put brackets after. So if this is true, if this returns true, then we know that there's no data. Now, what are we going to want to pass into these functions? What do we need to do in these functions? Well, if it's true, then we need to create a new player class, and we need the player. So let's have player as a parameter, and let's also have the result as a parameter as well, just in case there is a existing result that we can load. So we need the result and the player that we are loading in. So down here as well, we can add the player and the result is just going to be an existing class in the database. So now we've got the loading working, we now need to make sure that the save works. And to do the save, we have this save function that we created earlier, and we're going to use the save function to set the data into the table. So how do we set data? So in our table, we have our unique identifier, which is our user ID, and we also have the player class, which is going to be one giant JSON table. So when we save data, we're going to need the player class. We're also going to need player ID. We need that player ID as our unique identifier. So we're going to use the player ID and the player class. So now we've got our player ID, player class parameters that are going to come through in this save function. How do we even save data? Well, it's going to be the same thing as up here. We need a pcall success. Let's call it error. So we've created a pcall again, and the pcall, remember, is just, it tries to do it. If it can't do it, if there's an error, it will just skip to the next line. It will just ignore the error. And in this one, we're not going to return anything like we did up here with the return. So we don't have a result. We only check for an error. We don't have any results. So how are we going to save our player class? Well, we've got our player class here, and we want to save our player class as a JSON file. We're going to save it as JSON structure, and we're going to use the HTTP service here and call it JSON decode. Now what JSON decode does is it takes a table in Lua and it converts it into the JSON format. And what are we going to store? First of all, we need the player class, and then we need to store that JSON in the player class database. So we need to get the DB and we need to set async this time. So when you're getting data, you get async, set data, you set async. And when you set async, you need a key, which is your unique identifier. Our unique identifier is the player ID. And we also need the JSON structure. And the JSON structure is just our table. So this should save the player class to the database. So now we can set up the player leaves function. So this function is going to run when a player leaves the game. So all we want to do when we leave the game is save. So we can run the save function from inside the player leave. If you remember with the save function here, you might have to put this above. It might throw an error if we don't. This save function, you have a player ID. So we need the player ID and we also need the player class. So when the player leaves the game, we're going to assume that we've already got the player class created, because when they join the game, that is when we create the player class. So we're going to assume that it's already in this player class's table. Now we can get the ID by just doing the player service get ID function. You can do the get username by ID async. Probably easier to put it in a variable of its own because we're going to use the ID twice. So we're going to give it its own variable, and then we're going to put in the player ID, and then we're going to do the player classes, and then we're going to reference the player ID. Player class in the player classes table will be held as the player ID. So when we reference it here, it will give us the correct player class. Now this will save the data when the player leaves. So the final event we need to set up is this bind to close event, and this event basically runs when the server shuts down. So how are we going to do this? Well, we need to loop through all of the player classes and save each one. So we're going to use a concept from the previous video. If you haven't watched it, I'll put a card in the top right, but we're going to use functional programming to make this work. So in the top right here, we're going to create a new module script, which is the purple one, and we're going to name it for loops. The module is going to return a table, and this table is going to include a pairs for loop, and I'm pretty sure that's all we're going to need for now because our game isn't going to be that big. It's just going to be a player class. We just need a pairs for loop. Now we can write our usual pairs for loop in here. We have the key and then the value in pairs data, and in our function we're going to pass through the function and the data. So our function and data. So we've got our function and data being passed into this pairs for loop. It will run through each key in the data, which will be our table, and for each class we want to run our function and pass in our key and value. It would be the user ID, and this one will be the player class. That works perfectly because our save function also has player ID and player class as the parameters, so we can just push our save function into this for loop with functional programming. And the way we do that, if you remember from last video, we require the module. So we go script.forLoops. We have to call the pairs for loop, and in our brackets here, our parameter bracket, we're going to put save as our function. We're also going to put the player classes table. Now this line of code here basically going to run this function with the parameters save and player classes, and for each value in the player classes table, it will save each of their pieces of data. And now every time the game shuts down, we'll put server shut down. There we go. We can put a print statement in the player joined as well. So that is it for now in the server. We now need to create the player class so that we can add them to the player class table. So to create our player class, which is the main part of this video, we're going to use object-oriented programming in Roblox Studio Scripting. And we did this in the last video. Again, go watch that if you haven't. We're going to create a new module script, and again, it's going to be called our player class. In this player class, we're going to want to find our player class table. Now how these player classes work is basically all of the methods are stored in one table, and then all of the properties are stored in another table, and then you connect the two tables together using meta tables, which allows you to use the properties within the methods that belong to that class. So on the screen it shows you the table that will contain the methods, and then there will be the table that contains the object attributes, and they are two separate tables. So when we create our player class here and we're going to create a table, this will be our methods table. This is what's going to store all of our functions. To make this work and to intertwine this with our properties method, we have to add this line that will determine the behavior of this table. And to do that, we do player class dot underscore underscore index equals player class, and this basically results in something called inheritance. So let's say I had two classes, a doctor and a bus driver. They both have partial attributes that are similar, like name, height. Every human has a name, height, but there are also also some different things, like a doctor might have the hospital they work in, and a bus driver will have what bus they are driving. So what this line allows you to do, it allows you to create a parent class that you can reference. So the name, age, height can be in this one, and then the bus driver class and the doctor class could be two different classes, but they can reference the same objects from the parent class. So this line is very important in terms of object-oriented programming in Roblox Studio. Just always put it in, even if you don't understand it. Now, the next thing we have to write is the constructor, and I went through this a little bit in the last video, but the constructor constructs the object. Remember, when we create a new object, we're basically creating a new thing of itself. So say the class was a person, we're creating a new person. So to define our constructor, we can call it as a function, but we need to add player class because it's part of the table. We need to put it into the player class table, and then we do .new, and we are going to want to put the player into this. And another thing we want to do as well to make this work is pass through itself. The self isn't exactly a keyword, it's a variable name. It allows you to kind of define the properties as if they belong to the object that you're working in. For example, when we create some properties later, we'll use the self keyword, and it kind of acts like, oh, this name belongs to that specific object. So what we're going to do first is ignore this self in the parameter for now. We're just going to work with creating a new class. I want to create a new self table, but we want to set it as a meta table. A meta table is a table that allows a different table to manipulate. If I put a new table here, and then I set the player class table to be the second parameter of this meta table, if I try and find something in this table and it doesn't exist, but it does exist in the player class table, it will use the player class table's value instead. So the self only carries the attributes, but the player class will carry all of the methods that reside in that player class. Let's create a few attributes for our player here. So we can do self dot, and remember self is a table, so self dot is how you define a table here. So self dot name equals player dot name, self dot character equals player dot character, self dot coins equals 0. So let's say the player wants cash, that you want cash in your game. Self dot level equals 0. Let's say the player has a level, we could do self dot level equals 1. And these are all attributes that you can store. You can store anything in the player's self table. Okay, so this is how we create the basic class. But what if the class already exists? Because you remember, in our server, we're going to try and get the data out of the database. Well, this is why we're passing in this self method. And basically, when we get the data from the database, we're going to create a new player class, but we're going to pass in the stored data stored in the database into this function. So in the constructor, we need to check if self exists, if we've got the data from the database and we've passed it in to the class. If this exists, then we can set the self table to be this self table instead of creating a new one, because the old one that we saved is going to contain all of these attributes just in the table that was saved in the previous session that was played by the user. So what we can do is check if self, then set a meta table, and we want to create a new meta table here because we don't want to just return self here. We want to set the meta table of self to be the player class. We don't want to just return self because we have not set up the meta table connection between player class and this self function that's being pulled in. That meta table connection does not get saved when you save it to the database. You have to re-establish the connection between the player class and the self table. If you don't set this meta table, you won't be able to access any of the functions that will add to the player class. You'll only have the attributes, and it will just turn into a normal table. And obviously we need the end here, and that basically sets up our constructor. What I also want to do here is, because we're setting the player character when the player joins, I just want to make sure that the player character actually exists, and I'm going to do that with a task.wait, and I'm going to repeat until player character is not equal to nil. Once it's not equal to nil, once the player character actually exists in the server lobby, we'll be able to create this new class. So that is our constructor created. That is the hard part of creating a class, and the next part that I want to do is create the functions that go inside the player class to allow you to have some functionality within your class. So when we want to set the character or set name, we can do player class, and we use a colon here to define a player class that relates to the object. So we use a colon and we do set character, and we can pass in a character, and we can do self. We use self because that is the table that we're connected to, and we can do self.character equals character. We can do the exact same with the name. There you go, self.name is equal to name. We've got the set character method and the set name method. This will just change the character to the character we put in, and this one will change the name that we put in. You can add any function that you want here. You can add teleport player. You can change the player's C frame to anything you want. It's that easy, and you can do anything with the player all in this one script. So now that we've got the player class set up, we want to go back to our server script and we want to manipulate this onJoin table. And if you remember from earlier in the video, it's true if there was no data found in the database, and it's false if the player data was found. So this is when you join the game. If no data was found, we're going to create a new class. So local player class equals, and this is the syntax to creating a class. So we need to reference the module script. We also need to return. I didn't return. So we need to return the player class from the module script as well. If we don't return this, we're not going to get our player class table with all our methods, which means that we won't be able to create a new class. We can do require, and we're going to get our module script. So script.player class. So we've required our module script, and we're going to do .new, and this will instantiate a new player class. And as you remember, we have to pass in two parameters here. We've got player and self. Now we know that when the player is spawning in for the first time, we don't have a self to pass in. We don't have a table of attributes that have been saved. So we can only pass in the player. So we can just pass in the player and it will set self to nil. And it means that this will be nil. So now this player class is connected to the player. And what we actually want to do is add it to our player classes table because the player has just joined the game. So we want to reference the player classes. Remember, we want to access the player classes through their ID. So we want to get the player's user ID. So if you remember, we use the player service to get their ID using the player.name. This will now give us a new entry in our table with their unique user ID. And we can now put equals, and then we can put our player class. And this now has a entry in our table here. Now what I actually want to do is when the player joins, I want to print out the player class that we've just made, just so I can show you what happens when we run and test the code. And then I want to add some gold. So in our player class, I want to add some gold. So I want to create a function that adds gold. Now add coins is going to add the value to the coin. So we can now do player class colon add coins, and let's add 50 coins to their account. At this point in the test, we're going to disconnect from the game, then we're going to relog and see if our data has saved. So the player data will be found. We're going to load the data. So we've got our result, which is our self table with our attributes. It's only going to contain the attributes, remember, but we do need to create a new player class again. So what you can do is just copy this line up here because it's exactly the same, but this time we want to pass in our result, and this will set the attributes of the saved data to be the attributes of your new class using this line here. Now the one thing with this though is because we have this line here, it will return this and it won't set the name or the character to be anything because the player name and the player character have not been saved or defined in the database. So we do need to call the player classes set name and set character functions, which is why I created them at the start. So we want to set it to the player.character, player class, colon, set name, and we want to set the name to be player.name, just like that. So we've created our player class. It should be exactly the same as the one that we created up here when we rejoin the game. Now the final thing I want to do is add the player class to the entry in the false function. We've done it in the true function, but I do need to do it in the false one as well. So we need to add it to our player classes table, and we need to get the ID of the player. You can just copy and paste this exact same line, and this will add the player class to the player classes table, and the key will be the user's ID. And if you followed along, we have now completed our first fully functional database saving player class. So on the first test run, the player class didn't save the data properly. When we set the player class, I didn't realize that when we passed in the result here, we didn't decode it from JSON, and it's still set in JSON data, and when we pass it into the parameter, the result won't actually go in because it's in JSON format. All we got to do now is change the result. We just need to decode it from JSON into its respectful table. We need to go into the result here, and we just need to do HTTP, and we need to do JSON decode, and we can decode our result. Apparently, for some reason in the save function, it was basically passing in the wrong data and it was messing it all up. So let's try this for the 17,000th time. Okay, no data was found. Join for the first time. Both player classes are correct. We got our 50 coin player class. I'm going to leave, and then I'm going to rejoin the game, and hopefully our data was saved correctly. There we go. Finally, our data was saved correctly. Our character is the same character. Our coins are 50. Our level's 1, and our coins obviously saved. Remember, our default is 0, but the coin saved. So along with a few bug fixes at the end, we have made our complete player class, and it works and it's fully functional, and we've used a bit of functional programming as well. Kind of incorporates all of the different things that we learned in the previous video. In the next video, I want to start talking about server client communication with classes. I want to talk in depth about how to make efficient event scripts in Roblox Studio, but hopefully you found this helpful. All the code that is fully functional and working will be in the description. You just need to put it in the server script service for it to function. And remember, the player data data should be on the server, otherwise exploiters will hack your game. If you didn't understand anything in this video, please let me know in the comments and I will answer all questions that are given. And if you want to see how I create full games and full devlogs on different types of games that I've been creating, then please let me know, because I will be happy to do that as well. And if you did learn something today or managed to use this in your programming, leave a like on this video and subscribe to the channel to not miss another one. So that's it for this Roblox Advanced Scripting tutorial. I'll see you in the next video. Thanks for watching and see you in the next video.